6, we're going to learn the first way of solving quadratic equations, and that's going to be by factoring. Now let me make this little disclaimer right away from the beginning. Not all quadratic equations can be solved by factoring. Not all quadratic equations can be solved by factoring. Because what did we learn back in chapter 7 when we were learning about factoring?
That not everything can be factored.
Not all polynomials are factorable. So if it can't be factored, if the polynomial can't be factored, then we can't use the factoring method to solve it. We're going to have to rely on something else that I will teach you, because there's more than one method. Today we're going to learn this one. Today I'm going to tell you, though, you can solve all of them, so you don't come back tomorrow and say I couldn't factor it. Okay. You don't get to use that. So to solve quadratic equations, find the zeros of the function. We just talked about that while correcting. If there are 2 zeros, how many solutions? 2 solutions. And we call them real solutions. In other words, they're a number from the number line. If there's 1 zero, there's 1 real solution. Well, if there are no zeros, there'd be no real solutions. Okay, what would that look like if there were 2 real solutions? What would the graph have to do?
It would have to be going either down across the x-axis or up across the x-axis.
It has to, we know they either have to open up or down, but we know that it has to cross the x-axis in 2 places, doesn't it? To get 2 solutions. If it's only going to have 1 solution, what would be the case? What's happening
The
then?
vertex is on the x-axis.
The vertex is on the x-axis. Whether it's opening down or up, it doesn't matter. The vertex is on the x-axis. Then there's only 1 solution. What would no solutions be then? It's not on the x-axis. It's not on the x-axis or ever cross the x-axis, right? What do those look like? When they open up, their vertex would have to be where? Above the x-axis. If they open down, the vertex would have to be below the x-axis, and then there can't be any solutions. Okay. So every quadratic equation has a related quadratic equation of ax squared plus bx plus c equals 0. In other words, we replace the y with 0. We're looking for the zeros of the function. So we can replace that y with 0. Well, we also need to apply a property called the zero product property. Tell me this. If I take 0 times 7, what do I get? 0. If I take negative 5 times 0, what do I get? 0. If I take 0 times 0, what do I get?
0.
So in other words, if at least one of the factors is 0, the product will always be 0. So we are going to use that if one of the factors, at least one of them, they both can be, if so be it, but if at least one of them is 0, then the product's going to be 0. So we'll use that to help us solve also. So here's what we're going to do. If the equation is not set equal to 0, we'll make sure we get it there. So we got to set the equation equal to 0 first. So if there's a y there, we'll replace the y with 0. If there's not a y there, and it's already set equal to 0, we're good to go. If we don't have a y and it's not set equal to 0, we'll rearrange it till it is. Then we're going to factor the polynomial part of it, the ax squared plus bx plus c, to rename it. Just like we did in our factoring practice. Rename the polynomial. And then we will use that zero product property to find our solution or solutions. Okay? Our solution or solutions. That's not really a sentence. Okay. So let's just go to work practicing. We're going to practice 3 of them. Number 1, x squared plus 4x minus 21 equals 0. It's already set equal to 0, because that's always going to be our first thought. Is it set equal to 0? Then we're going to identify our a, b, and our c. 1, 4,
and negative 21.
Negative 21. And notice what I have there. What's this method that we're going to use?
Diamond.
We're going to use the diamond method to factor. So since a is equal to 1, I can just put what up here? Negative 21. And what goes down here? 4. So remember, what am I really looking for? Numbers that
Add up to 4 and
Add up to 4.
multiply to negative 21.
and multiply to negative 21. 7 and negative 3. A is equal to 1. When A is equal to 1, we're ready to go right to renaming it. We're ready to set up our factors. We don't have to do factoring by grouping. So what is our new name for x squared plus 4x minus 21?
7 or 7 plus
X.
or x.
No.
It's x plus 7
X plus
times
7.
x minus 2.
X minus 3. Oh, that was just a few days ago, guys. So when we factor it, we rename it. So if we FOILed that back out, it would take us back to that trinomial. So now we've done the factoring to rename it. Now we're going to do our last step, which says use the zero product property. Well, if we can get one of our factors to equal 0, then multiply times the other one, we'd get 0, wouldn't we? So we need to know what number or numbers could create a factor of 0. So we set each factor separate of each other equal to 0. In other words, we're solving for x. We want to know what would make that factor equal 0. So if we had x equals negative 7, that would make that factor equal 0. And then it wouldn't even matter what happened in the other one, because in fact we put negative 7 in it, we'd have negative 7 subtract 3, well that would be negative 10, but the first factor would be 0. So 0 times negative 10 is?
0.
0. Okay, but then we got the other factor that has an x also, and we say, okay, what would make that factor equal 0? It is 3. So when x equals 3, that's also a possibility, because 3 take away 3 is 0, and 3 plus 7 is 10, and 0 times 10 is still 0. So both of these are our solutions. We have two real solutions. Okay, I want you to verify that on the graph. I want you to go put that into y equals. I want you to put in our x squared plus 4x minus 21, and see if it does cross the x-axis at those two locations. Now, I'm just going to make a little guess here that you're not going to see the full parabola, are you? Oh, I wonder why.
It's a pretty huge parabola.
It's a pretty big parabola. And we just have a 10 by 10 window, don't we? 10 going that way, 10 going that way, 10 going up, 10 going down. Or in other words, we really have a 20 by 20 window. But why don't we see the whole parabola? With that, from negative 10 to positive 10, negative 10 to positive 10 window. Why don't we? Where's the vertex at, do you think? It's opening up, do you think? Do you think it's opening up or opening down? Hotel?
It's opening up.
It's opening up? How do we know?
But it's a positive.
Because we got a positive A value too. Yeah, it gets skinnier down this way. Yeah, that would be one reason too. But the A value is also positive, so we know it's opening up. Okay, well, where would the vertex be then? Up here or down here? Way down here. And what else do we know? The y-intercept's negative 21. Do we see negative 21 on the y-axis on here right now? Can we see the y-intercept on there?
No, but if we go second.
Well, let's go to window. Let's go to window. Let's change our y minimum. We want to get down there so we can see the rest of our parabola. So let's go change y minimum to negative 25. Negative key is next to the enter key in parentheses. Negative 25. And I want you to change the y scale to 2. And then I want you to say, now can you see the whole parabola? Yeah?
Oh, yeah.
Yeah. So we didn't have a big enough window to see the whole thing, do we? This is one of those ones that if I had to graph it, we'd have to have a better coordinate plane for it. Now tell me, does the parabola cross the x-axis at our two locations, negative 7 and positive 3? Does it cross? Does it look like it does? Okay. How could you verify that it's for sure? Go to the table, second graph, and in the table, where x is equal to -7, what should be true? So y better be 0, is it? Can we do well? Okay. How about 3? When x is equal to 3, what's y? 0, that's good. Okay, are there any other places where y is equal to 0? Probably not. Do you think there could be? Can this parabola cross the x-axis anywhere else? No, you can't. Okay. Okay, let's go to the back and practice another one. In fact, you're going to do this one on your own while I do it. Okay? You guys do it. This is you know now. Solve x squared plus 4x minus 5 equals 0. And then it says, let's check with the graphing calculator. So if you've got it solved, why don't you go ahead and put that function into square out the one end, and there's only one parabola to deal with. Why don't you do a zoom 6 again also to get back to a standard window, and then see if that's what holds true. Does it cross the x-axis at those locations you've got? First of all, since I'm not checking with the graphing calculator, does anybody have the same solutions I do? X equals -5, x equals positive 1. Okay? Do we check out according to the graphing calculator? Okay. Now, what if next week I give you this test on chapter 8 and I won't let you use these graphing calculators? And you're like, oh my goodness, it's the last period of the quarter. I'm sitting with a really low C right now. I really need to do well on this test. Okay? And so you want to make sure you have the right answer for this, and I'm going to guess you're not going to really want to have to grab it, but you would wish you had a way you could check it really quickly without that graphing calculator. What could you do to check without the graphing calculator? Plug the numbers into the equation and make sure you get 0. Let's try it really quickly here and make sure it works. So what's -5 squared? 25. And what's 4 times -5? -20. And then we have our plus, I'll make that plus of -5 at the end. Is that 0? 25 plus -25, that's 0. Okay, let's do it with our 1. What's 1 squared? 1. And what's 4 times 1? 4. And then we have our plus of -5. Is that 0?
Yes.
Yeah, 1 plus 5 is, 1 plus 4 is 5, and 5 plus -5 is 0. Okay, so really, that was harmless. It didn't take us very long to check it at all, did it? Okay, questions? Okay, then let's do this last one. Number 3. Notice it's not set equal to 0, so we gotta get it there. So what are we gonna do? Add 9 to both sides. Add 9.
Your attention, please. Please dismiss the baseball team players for their game on the field. So dismiss them at this time. Thank you.
There's our quadratic equations that equal to 0 now. And now we can do what?
Factor.
Factor it. Let's factor it to rename it. So we need our A, B, and C. And then we will put it into our diamond. What goes up in our diamond?
C.
C, which is 9, and down is
-6.
-6. What numbers are they? Multiply to 9, add up to -6.
-3 and negative.
-3, -3. Okay, that means then our renamed
X minus 3.
x minus 3, x minus 3 equals 0. We just renamed it. What's true about those factors?
They're the same.
They're the
As
same.
long as there's only
So
going to be
there's only going to be one solution, because if we solve both of them, we're going to get the
same.
same answer. So let's not be redundant. Let's just solve it once and get x equals 3. So this time we only have one solution. What does that tell us about the graph?
It's the vertex.
It's the vertex. It's sitting on, is it opening up or opening down?
It is opening up.
It's opening up. Okay, I'm easy on you today. Every time you do them, a is equal to 1, and it's opening up. Tomorrow, we're gonna put our thinking caps on and move it tighter. Okay? So, you may keep your graphic calculator to check your answers while you're working on homework, or you may cover them up, and return to the case. You may start on your homework.